Okay, so I'm going to go through the volumes of Revolution exam questions that I set you. So the first question was about the bird bath, and it asked you first of all to suggest the maximum depth of the bird bath, given that the curve that we were working with was y equals 1 plus k times x squared. And we'd been given a graph of it that looked something like that. This is 0.2 and this is minus 0.2. So, and on the original drawing of the bird bath, we'd been told that this was 1.16. So we know that the y coordinate there is 1.16. So what we're looking for there, we know it's symmetrical about the y-axis, because this is just a translation and a stretch of an x squared graph. So we're looking for what the intercept is here. So in other words, what's the value of y when x is 0? So when x equals 0, y equals 1 plus k times 0 squared, which means y equals 1. So that means that the intercept there is 1. And therefore the depth of the bird bath is going to be the difference between those two y values, in other words 0.16, which means that the depth is 16 centimetres. Okay, so that was just for 1 mark. Part B was find the value of k. So what I know there is that the y-coordinate when x is 0.2 is 1.16. So I can take my equation and say when x is 0.2, y equals 1.16, and therefore 1.16 equals 1 plus k times 0.2 squared. This is 0.04. So I can take away 1 and then divide by 0.04, which gives me a value for k of 4. And therefore, my equation of my curve is 1 plus 4 x squared. Right, you were then asked to find the volume of the concrete that was required to make the bird bath, according to the model, giving your answer in metres cubed. So the first thing I did here was work out what the volume of this would be as a complete cylinder. And then I'm going to work out the volume created by rotating this bit of the curve around the y-axis, and then I'm going to subtract the 2 because this is obviously hollow, and what I want is what this would give me. So this would be, if I think of this whole bit here as a cylinder, this would be a cylinder of radius 0.2 and height 1.16. So therefore the volume of my cylinder is going to be pi r squared h, where r is 0.2 and h is 1.16, and that gives me 0.1458 metres cubed. And now I'm going to use volumes of revolution to calculate the hollow part, which I'm going to subtract away. And it's a rotation about the y-axis, so that is going to be pi times x squared dy, and then between y limits as well. So I'm going to need my 1 and 1.16 as my limits. But I also need to actually rearrange this equation of the curve here to give me x squared. So I'll do that up here. That's going to be y minus 1 over 4 is going to be x squared. But for ease of integration, I'm going to think of that as a quarter times y minus 1. So when I come to do my integration here, it's going to be pi 1 and 1.16 is my limits. A quarter y minus 1. So I'm going to take the quarter outside my integral so that it makes my integration a little bit easier. And I'm going to add 1 to the power, so y squared, divide by the new power. Same for the 1, add 1 to this is y to the 0, so it's going to become y to the 1 divided by 1. And then I've got my limits. And that will give me y over 4 times 0.6728 minus 1.16 minus a half plus 1. And that is works out to be 8 over 625, which is 0.010053096 ... meters cubed. And that's now what I need to subtract from my volume of my cylinder, which was 0.1458. So the concrete required is 0.1458 subtract 0.0100539096, and that is 0.1357469035, which is 0.136 meters cubed to 3 significant figures. Okay, so that is the workings for the first question that you had to do. The second question was about a bottle, and we were given a part of the whole bottle as a curve, something like that. And we were told that the value of x at this point is 1 and the value of y at this point is 4. And we can also tell from the dimensions that we were given the height of this bit of the bottle was 14. So we know that the y coordinate there is 14. And we are also told that the height of this bit is 4. So we know that the y coordinate there is 18. Now, something interesting happens here on Dr. Frost, because I think it's telling me an answer that I know to be wrong, because I've looked at the mark scheme as well. However, it tells me 100% of you got it right. So that either means that the answer on what I'm looking at wasn't what Dr. Frost thought it was, or you all made the same mistake that Dr. Frost has made. And that would actually explain why you got the second bit of the question. Most of you got it wrong. Because you would have been using the wrong values for A and B. So I'm going to go through this now, and you can sort of try and work out how well this fitted with what you did. So the first thing is that I'm told my curve, or the curved bit of my wine bottle, is going to be modelled with an equation like this, y equals ax squared plus b. And I'm asked to find A and B. And I know that when x is 1, y is 18, because I've worked out this coordinate right here. So I can substitute that in, and I'm going to get 18 then is a times 1 squared plus b. Well, 1 squared is just 1. In other words, 18 is equal to a plus b. And I also know that when x equals 4, y equals 14. So I can substitute in those two values, and that will give me 14 is 16a plus b. So I've got a pair of simultaneous equations, and I'm going to subtract from this one, 14 equals 16a plus b. I'm going to subtract the first one, which was 18 equals a plus b. And that's going to give me minus 4 equals 15a. The b's obviously are going to cancel. And now I can divide through to say that a is minus 4 over 15. So this is where, on what I'm looking at, Dr. Frost tells me it's 4 over 15, but it isn't. It should be negative 4 over 15. I can now subtract that back into well, I went for this one because it's only a plus b. So I've got 18 equals minus 4 over 15 plus b. So b equals 18 plus 4 over 15. And that gives me 274 over 15. So those are the two values. And that gives me an equation which is y equals minus 4 over 15 x squared plus 274 over 15. And it makes perfect sense that we've got a negative coefficient here because my graph looks like an upside down, doesn't it, x squared? So in other words, it must have a negative coefficient there. Okay, the next part of the question then was to find the volume of water that the bottle can contain. So my bottle is divided up into three parts, basically. I've got the cylinder that's sitting on the top. I've got the part which is going to be made by rotating the curve that I've just found the values of A and B for about the y-axis. And then I've got another cylinder at the bottom. And so my cylinder at the top, I was told that that was 2 centimetres. So in other words, it's got a radius of 1. And I'm also told that that is 10 centimetres, so it's got a height of 10. And then this bottom cylinder here, I'm told that this is 8 centimetres. In other words, it's got a radius of 4. And I'm also told that this is 14. So it's got a height of 14 centimetres. So I can work out the top cylinder. And that's going to be pi r squared h, which is pi times 1 squared times 10. In other words, 10 pi. And I'm going to leave it as an exact value until the very, very end. The bottom cylinder is going to be pi times 4 squared times 14, which is 224 pi. And now I'm going to work out the volume from this bit by rotating my curve about the y-axis. So the curved part, it's about the y-axis again, so it's x squared dy between two y limits. And those are the limits that I found all the way up here, 14 and 18. And also I need to rearrange this as well so that I've got an expression for x squared. So that's going to be y minus 274 over 15, and then divided by minus 4 over 15. So in other words, multiplied by minus 15 over 4. And so I'm going to have minus 15 over 4y plus, these 15s are going to cancel, the minus there and there are going to make a positive, so 274 over 4. So what I'm going to be integrating then is between 14 and 18, and it's minus 15 over 4y plus 274 over 4 dy. Probably would be sensible to take this quarter outside my integral again, but I haven't when I did this first time, so I'm going to plough on with keeping that inside. And now I'm going to integrate. So I'm going to add 1 to this power, so it's going to be a y squared, and then divide by 2, so that's going to become an 8 there. And then this one, I'm going to wind up with a y there. And now I'm going to substitute in my limits and subtract. And that will give me minus 1,215 over 2 plus 1,233 plus 735 over 2 minus 959. And when I work all that through, it gives me 34 pi. And again, keep that exact for the moment. So now I'm going to add together to find my total volume. And that will be the 10 pi that I found for the top cylinder, the 224 pi I found for the bottom cylinder, and the 34 pi that I found by doing my volume of revolution, which gives me a total of 268 pi, which is 842 to 3 significant figures. Now, I hope that helps. Sometimes Dr. Frost can mark things wrong because he didn't put it in exactly the way that it wanted. So, for example, if you didn't round it as it thought, or if you gave it as an exact value, it'll just tell you it's wrong, which obviously in an exam, although you might lose the final mark if you did that bit wrong, you would get the rest of the credit. So hopefully now I've been through that, you can see where you went wrong, if you went wrong, and hopefully that will help you.